Hello pre-calc counter students, here we are with finding expected value. And let's start with a spinning game. If we spin this thing, let's record what we won there. Well, it looks like we got 10 bucks. Cool. Cool beans. Spin it again. Lose one. And we'll count that in the red. 6, 7, 8. Two more. Spin it again. Oh, good. 10 bucks. Okay. We did pretty well there. So we end up with 10, 1, 2, 3, 4, 5, 6, 7, 8, 80. 80 minus 13, or we ended up with 67. So on average, that was 6.7. An average gain of 6.7 per turn. That looks about right. Now let's do this more exactly here. If you roll a green, you gain 10. Your chance of a green is 3 out of the 6 equal sections, so that's a half. A red, you lose 13, and there's a 2 out of 6, or 1/3 chance of losing that. And yellow, you lose 1, there's a 1/6 chance of that. Now the expected value, you have to multiply each gain or loss by its probability and add the products. So 10 times a half, plus negative 13 times a third, plus negative 1 times a sixth. So we have 5 plus negative 13 thirds plus negative 1/6. So that's 5, and negative 13 thirds is negative 4 and a third plus negative a 6. So we're down there a bit. 4 taken away from 5 is 1, and negative a third and negative a sixth. So let's make that negative 2/6 and negative a sixth is 1 and negative 3/6. 1 plus negative a half equals a half. So we only expect on average to get a half per turn, half a dollar, and we ended up in our case of getting 6.7. I think we got pretty lucky there with our tens. Okay. Let's see if that makes sense. Minus 4 and a third, yeah. And then minus a sixth. Yeah. Yeah, 2/3 minus a sixth is a half, yeah. Okay. Now here's the definition of expected value. Expected value is you take your first possible value times the probability of that value, plus the second times the probability of that value, plus the third possible value times the probability of that value, all the way up to the nth possible value times the probability of that value. So in sigma notation is for summation from I equals 1 to n of x sub I times the probability of x sub I. And essentially you're doing a weighted average. You're using the probability to weight things. Now a game is fair. A game is fair if the expected value equals 0. That is, your wins and losses should balance out. So let's make it a fair game with this spinner. To make it harder, never use the same digit more than once. We went 1, negative 2, 3, negative 4, then negative 5, 6, negative 7, and 8. 4 to 18 that way, 12 and 6, 18 that way. So expected value would equal 0 because I'm going to multiply each of these by an eighth. There you go. Now, example 1. If the sum of two rolled dice is 8 or more, you win $2. If not, you lose $1. Show that this is not a fair game. Well, if you roll 2 dice and the sum is 8 or more, so let's look at our dice chart again. And we get 8 or more when basically you have a 6 and a 2. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You get the 8s here, 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 and here, and 8 or more then. So the probability of 8 or more This equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 out of the 36, which reduces, take out a 3, to 5/12. Now, let's actually do the expected value. We have to take winning $2 times the probability of 8 or more, 5/12. Now, losing $1 times what's left. Well, the balance of 5/12 is 7/12. Everything else you lose $1. So you get 10/12 and negative 7/12 is 3/12 or a quarter. So on average, you're winning 25 cents a play here on this game. So it's not a fair game. It's good to you if you're the one rolling the dice, but the person providing the money, it's not fair. So to have a fair game, the $2 winning should instead be what amount? So the $2 winning should be, so the amount of the $2 winning should instead be what amount? So the new amount, let's let the new amount equal X. So X times, if the chance of that amount happening is 5/12 plus negative 1 times 7/12. You want that to equal to 0. So 5x over 12 equals 7/12. 5x equals 7. X equals 7/5, or 1.4. So you want the winnings to be $1.40 to have it be a fair game. Now, in certain states of lottery, 6 numbers are randomly chosen without repetition from the numbers 1 through 4. If you correctly pick all 6 numbers, only 5 of the 6, or only 4 of the 6, then you win 1,000,000, 1,000, or 100, respectively. What is the value of a $1 lottery ticket? So we can see by what you win. So we need some probabilities here. Correctly picking all 6 numbers. Well, there's a total combinations is 40C, choose 6. We'll go to our calculator on that one. 40 choose 6 is probably going to be pretty big. Get out your old NCR in the catalog. 40, 6. And we end up with 3,838,380. 3,838,380. Okay. So the probability of correctly picking all 6 is just 1 in that. Of all 6 numbers correct is 1 in 3,838,380. The probability of 5, getting 5 of them right. Let's figure that out. What's the chance of that happening? Well, for that, think of it this way. You have 6 winning numbers. Let's just say it's fixed ahead of time. 6 winning numbers. And you're going to pick 5 of those. So it's going to be 6 choose 5. And then your pick, your 6th pick, is going to be from the losers. So it's 36C1. So let's see what that works out to be. That's a lot more than 1. So it's going to increase the probabilities. 6C5 is just 6. And 36C1 is 36. So we end up with 216. 216 out of the same 3,838,380. Now the probability of getting 4 correct. Now we've chosen 4 of the correct numbers, and then from the losing numbers, I'm sorry, this should be 34. Right, this is 30, there's 34 losing numbers. 34 times 6. 204. 204. Okay. Now 64 times 34, C2. So 6C4. That works out to be 15. 34C2. 34, 2, works out to be 561. So we take 561 times 15, and we get 8415. So the chance is really going up out of 3838380. So we've got the probabilities now. Now you have to multiply them by their winnings. So you get 1 million for that first one. So $1 million times 1 out of 3838380 plus, I believe the second one is not so big, 1,000. 1,000 times 204 over 3838380. And then finally, we only get $100 for matching 4. 100 times 8415 over 3838380. Plus, we win nothing, so I don't even bother figuring out the probability of not getting one of those three, because it's just going to zero out. So, I'm going to take 1 million. 1, 2, 3, 4, 5, 6 million plus 1,000 times 204 plus 100 times 8415. And I'm getting 2,045,500. But that's being divided by 3838380. Divided by 3838380. And I get 53 cents. 53.3 cents, 53.29, or 53 cents. So if you spend $1 on the lottery ticket, you're only going to get 53 cents back on average. So the value of it then, we have to do the subtraction then. The value of a $1 ticket is 53 cents, so you can say 1 minus 53. Well, see, it's like this. You lost $1 buying it. Now, on average, you add 0.53 cents. So the value of this ticket is actually negative. You're losing money on each ticket. 0.53 minus $1. You're losing 47 cents lost on average per ticket. Okay? Now, let's look at another game, if you will, the game of insurance. 18-year-old student must decide whether to spend $160 for a 1 year's car collision damage insurance. The insurance carries a $100 deductible, which means that when the student files a damage claim, the student must pay $100 of the damage amount, with the insurance company paying the rest, up to the value of the car. Because the car is only worth $1,500, the student consults with an insurance agent who draws up a table of possible damage amounts and their probabilities based on the driving records for 18-year-olds in the region. And here's what they came up with. If you have an accident costing $1,500, the payoff is going to be $1,400 because you have to pay a $100 deductible. The chance of that happening is 5%. An accident costing $1,000, that means they're going to have to pay off $900, and the chance of that happening is only 2%. Accident costing $500, they'll pay $400. That's less than the $100 deductible. Probably happens 0.03. No accident, they don't pay anything. It happens 90% of the time. What's the expected value of this insurance? So for 1 year, we take 1,400 times its probability, 0.05, plus 900 times 0.02, plus 400 times 0.03, plus 0 times 0.9. We don't really have to do that part. So let's take a look at 1,400 times 0.05 plus 900 times 0.02 plus 400 times 0.03, and I'm getting $100. But the thing is, you're paying $160 per year. So $100 paid out by the insurance company, and you're paying $160, plus you're also paying the deductible on these other ones. Now let's look at that too. So that's the insurance company's cost. They're going to on average pay out $100 for your accidents. Let's look at your cost, the student cost, for the course of a year, because you're spending $160 for 1 year's collision damage insurance, okay? Plus the $100 deductible. So you're going to pay $100 when you have an accident costing $1,500. You're going to pay $100 when you have an accident costing $1,000. You're going to pay $100 when you have an accident costing $500, and that happens 0.03 of the time. You don't pay anything if there's no accident. So let's see what that adds up to. 160 plus 100 times 0.05 plus 100 times 0.02 plus 100 times 0.03. And you end up paying another basically $10, 160 plus 10, or $170. So it is a net loss to student of $70 per year on average. All right? Now they say only minus 60, but the deductible, I think you have to put in as well. That's why I'm saying minus 70. Okay. Flange out.